I'm using principle of mathematical induction as I've explained in the last video that and also the same type of problem I have solved, that is the sum of natural numbers. This is sum of square of natural numbers. Okay, so first three steps we have to follow, and the first one is consider this as an equation which is p of n. So 3 square so on till n square is n into n plus 1 into 2n plus 1 by 6. And next is the first step is check whether p of n is true for n is equal to 1. That is, on LHS the first term is 1 square, and on RHS we have to substitute the value of n as 1. 2 into 1 plus 1 by 6, which is 2 into 3 by 6. 2 3s are 6 and 6 cancels, which is 1. Okay, 1 square is also 1. Therefore, LHS is equal to RHS. Okay, P of 1 is true. Okay, thus P of 1 is true. And the second step is assuming. Okay, we have to assume that P of k is true. Okay, or P of n is true for n is equal to k, we can write. Okay, so we have to assume P of k is true. That is, P of k is equal to, in the place of n we have to substitute k. 2 square, 3 square, so on till k square is equal to k into k plus 1 into 2k plus 1 by 6. Okay, and the third step is we should prove that P of k plus 1 is true. Okay, for that, for our clarity, it will be very useful if you write this after writing this. Okay, it is 1 square, 2 square, 3 square and till k plus 1 the whole square plus is equal to, in the place of k you have to put k plus 1. Okay, so in the second step equation. Okay, so k into k plus 1 plus 1 into 2k plus 1 plus 1 by 6. Okay, so this is the one what we have to prove. We have to prove this one. Okay, if we write this, we'll get to know what we have to prove, and it will be very easy for us to prove. Okay, and using this we can tell that we should add k plus 1 whole square on both sides of equation in step 2. Okay, we have to add k plus 1 square on both sides in equation in step 2. That is 1 square, 2 square, 3 square, so on till k square plus k plus 1 the whole square is equal to k into k plus 1 into 2k plus 1 by 6 plus k plus 1 the whole square. Okay, and we can observe that in the LHS side we have got, okay, and only will work out on the RHS side. Okay, that is, here k plus 1 is common, so we'll take k plus 1 as common. If we take out the common, k into 2k plus 1 is remaining, and 6 by k plus 1. Okay, and so k plus 1 into k into 2k plus 1 on taking LCM 6. After that, we'll take k plus 1 by 6 as common out. So on multiplication, 2k square plus k plus 6k plus 6 will be remaining out. Okay, so by 6 and 2k square plus 7k plus 6. Okay, and we have to solve this to get, and 12 can be written as 3/4. 3 plus 4 is 7. So therefore, k plus 1 by 6 into 2k square plus 4k plus 3k plus 6. Okay, 3k plus 6. So k plus 1 by 6 into 2k, if I take common, k plus 1 is remaining, k plus 2. Okay, k plus 2 is remaining, plus 3 if I take common, k plus 2 is remaining. Okay, so therefore k plus 1 into k plus 2 into 2k plus 3 by 6. Therefore 1 square plus 2 square plus 3 square, so on till k plus 1 whole square is equal to k plus 1 into k plus 1 plus 1 into 2k plus 1 plus 1 by 6. Therefore, P of k plus 1 is true. Okay, this is the proving. Thank you.